So recording has started. So like I said, welcome to week 3. This week we're going to be going into Starknet proper. I mean, last week we were talking about Cairo and a lot of fundamental things. This week we're going to go into Starknet contracts. And tonight we have with us a new instructor from the Starknet Africa team. That is Mubarak Aminu. Mubarak Muhammad Aminu is going to be joining us. He's a smart contract developer who writes Cairo. So we are pleased to have Mubarak. Please celebrate Mubarak as he joins us. Mubarak, if you're here in the call, please kindly unmute and say hi.
Yeah, hi everyone. Can you guys hear me?
Hi. Yes, we can. How are you doing?
Yeah, I'm good. It's been nice to be here. I've been on the background hearing the whole introduction and all of that. So yeah, it's good to be here, right? So week 3, right? So we're going to start with introduction to Starknet smart contract, right? And yeah.
Awesome. The floor is yours.
Okay, I'm going to share my screen and kick off from there. Just give me a second to... Okay. Can you all see my screen?
Yes.
Yes.
Okay. So yeah, so this is week 3. I'm going to check the first part of the 3 part of this week 3, which is introducing you guys to Starknet smart contract, right? And just like I was introduced, my name is Mubarak Aminu, and I write basically I write Rust and Cairo. And so yeah, this sort of like the agendas for today's session, right? We're going to learn about Cairo programs, right? Which is on the back of what we've learned from week 2, right? Then we go into understanding what a Starknet contract is, right? And then we'll see the difference between a Cairo program and a Starknet contract, right? And then we'll look at a contract class, then we'll look at contract instance, and then we'll look at in functions and interface in Starknet. So yeah, so from our previous class, right, looking at what we've done from the previous class, I saw that we looked at like Cairo programs, right, and like how to write Cairo programs. So I wanted to get from the audience, right, who can briefly give me, like, explain to me what you understand by Cairo program based on the previous session that you guys had week 2, week 1. Anybody? Awesome. Okay, just a second. Let me. Trying to get the first person that raised his hands up. Okay, yeah, the first person, Afolabi, you can speak up.
Yeah, GM everyone. So we get to like understand that Cairo programs, there are verifiable, they enables verifiable computations which we'll be needing for Starknet, and the syntax are very much similar to Rust, almost the same thing, and it compiles, is a compilable program also.
Absolutely. So yeah, just like you said, right? That's a very good one. Yeah. So So yeah, what's a Cairo program? So basically, Cairo programs are like stateless programs, right? They're programs that don't have states, right? And they are designed to run on a virtual CPU, tailored for cryptographic constraint rather than physical constraint. So imagine you write a program, but you don't have access to states. So remember in your first class, in your FIQ1, right, you were taught about, I mean, the whole blockchain thing, right, whereby a lot of things are changing states, right, and all of that. But Cairo programs don't have states. So what they basically do is they allow you to sort of like create, to prove a particular computation, right? So if you write a program that says 1 plus 1 is 2, when you run that program and you give you 2, you can give it to someone else to prove that, okay, this program actually results to 2. So that's like on a higher level of what Cairo program is. So from the reading here, right? So Cairo also features what we call immutable memory model. Immutable memory model, meaning once a value is returned to memory, it cannot be changed, right? While while Cairo 1 provide abstraction to help developers manage constraint. So before the initial version of Cairo is Cairo 0, right? Which is a bit abstract from Rust. Then we have now Cairo 1, which is almost similar to writing Rust, right? So Cairo 1 provide developers abstraction to help them manage the memory, right? But it does not fully simulate mutability. So what do I mean by mutability? When I say mutability, I basically mean you can actually change states. You can change the variable, right? When you define a variable is equals to 1, you can actually change that variable to, like, you can add or increase that value to 1 or 2 or 3. That's basically mutating the state of mutating that particular variable. We'll see when we go down writing Cairo, when we start writing Cairo smart contract, right? But from you guys' previous experience, I know that you guys talked about Cairo programs, right? And you guys talk about writing variables in Cairo and writing mutable variables in Cairo also. And so yeah, that's like one of the advantage that Cairo 1 give you. It allows you to sort of mutate variables in a certain way that doesn't affect the ownership of that variable. So yeah, then another case is a major use case for Cairo is Starknet, right? Which is a layer 1 solution for Ethereum scaling. Starknet allow a single node to execute program, right, and generate correct computation, yeah, which can then be verified by an Ethereum smart contract, which significantly reduce computational power requirement and transaction costs while maintaining Ethereum security. So yeah, in essence, what this is saying is that you can prove a particular computation and take it to layer 1 and says, okay, I prove that 1 plus 1 is 2, and I give you 2. And you basically agree that, okay, 1 plus 1 is 2. So yeah, that's like basically what Cairo program allow you to do. So yeah, then we talked about the Starknet contract. So Starknet contract, it's basically a Cairo program that has states, right? So yeah, let's go into the explanation of what a Starknet contract is. So a Starknet contract, it's a program specifically designed to run within the Cairo OS, which is itself a Cairo program. Yes, when you write Starknet contracts, you run it in the Starknet operating system, which is a Cairo program itself. Remember I said the Starknet contract is a subset of Cairo program, right? And this contract can access and modify Starknet persistent states, communicate with other contracts, and interact with underlay underlying layer 1, which is Ethereum network, right? And yeah, Starknet leverage ZK Stack technology for scaling, right? Which provide fast, secured, and low computation, low cost transactions as part of layer 1 scalability solutions for Ethereum. So yeah, I'm very sure from you guys lecture, sorry, week 1 and week 2, you've been taught that the whole essence of Starknet is to scale Ethereum, right? And how does it does? It's by using ZK Stack technology, right? To do that. So yeah, this is, yeah, and here we come here, right? So for this part, right? Again, Starknet contract lives within the Starknet VM. So what I mean by VM, I mean the virtual machine, right? Which has a persistent state that the smart contract can access and modify, right? So you've been hearing me saying persistent state, right? So every smart contract by design is expected to have access to states, right? And the Starknet virtual machine give those contract access to those states, right? Starknet contract can store variables, right? Communicate with other Starknets, with other contracts, and also receive or send message to or from layer 1. Yeah. And like I said, right, Cairo is a native language for Starknet smart contract, which most fully realize the scaling potential of Starknet. Yeah. And that's the reason why before we introduce you guys to Cairo, before we introduce you guys to Starknet smart contract, we sort of like went over and taught you guys how to write Cairo programs, because Starknet contracts are written with Cairo. So yeah, that's all about here. So I'm going through all these slides, right? When I'm done with the slide, we'll go over to write code to see what it means to write Starknet contract, right? And so yeah, so you get to understand from all of what we talked about here, to sort of like go over it and see how it's been done when you start to write contracts. When you start to use your knowledge of Cairo programming, right, to write Starknet smart contract. I don't know if you guys are following me. If anybody have question, I'll sort of like entertain 1 or 2 questions, then we'll proceed from here.
I think there's a question in the chat.
Okay, awesome. Okay. Okay. Okay, so the first question, Cairo is Cairo program. Okay. The question is for the second one, right? Starknet OS was written with Cairo. Yes, Starknet OS is written with Cairo. Yeah. So that's why when you write your Starknet smart contract, it's being run within that Cairo, within that Starknet OS. So somebody raise his hand. Okay, the person has dropped his hand. Okay, so yeah, let's continue. So what's the difference between Cairo programs and Starknet contract? So yeah, we'll look at the entry point, right? So what do I mean by entry point? Entry points, it's basically like at like the point where you get access to a particular program. Like for instance, if you're coming from Web 2, if you're using JavaScript, Node.js, you want to get access, you use the word index.js, right? And then most at times you use the index function, right? So yeah, that's the same thing with Cairo programs here. With Cairo programs, you always have access to the main function that serve as the entry point for the program, right? While for Starknet contract, it doesn't have main function. Instead, it has multiple functions that can serve as entry points. So yeah, you have different functions, right, that can serve as entry points to that particular contract. Yeah. The second point that shows the difference between them is access to state. Yeah. Cairo programs run independently, right, and does not have access to Starknet state, while Starknet contract run on the Starknet network and has access to Starknet states, allowing it to read and modify blockchain data. So yeah, this is a very key differentiating factor between when you see a Cairo program and when you see a Starknet contract. You can, from the way they access the state, you'll be able to know that, okay, this is a Cairo program and this is like a Starknet smart contract. So yeah, then another key differentiating factor is the definitions and annotations. Now, Cairo programs are defined as standalone without any special annotation, right? While Starknet smart contracts are defined within a module and must be annotated with the Starknet column contract annotation. So you'll be annotated with this particular annotation. It's an attribute, right, that is being recognized by the compiler. Yeah. Then the fourth key differentiating factor between Cairo programs and Starknet contract is the execution environment, right? Cairo programs are executed in a general purpose environment, right? So the moment you install your Scarb, you can basically run Cairo programs and you're good to go, right? While Starknet contract are executed by a Starknet sequencer within a blockchain environment, right? So that's like a key differentiating factor between the two in terms of when it comes to the executing environment. And so yeah, we talked about a contract class. So are we all clear on the difference between when you see a Starknet smart contract and then when you see a Cairo program? Based on what I explained, can you be able to sort of like differentiate between the two? If you can differentiate between the two, just signify with an emoji. Awesome. Awesome. Yes, so Hillary, yes. So when we go to the part of writing Starknet contract, you will see how that annotation has been placed to make the compiler know that this is a Cairo program we're trying to write. So yeah. Okay, yeah. So let's move on to contract class. So contract class is the definition of contract, right? It contains the bytecode and the entry point, right? And what I mean by Cairo bytecode, I mean the low-level function implementation of that contract class. And then the entry point, just like I said, right? In Starknet contract, any function in that contract can serve as the entry point. It's just, for example, you have a contract that takes record of student in a class, right? Takes student in a class, it knows everybody's name, unique number, they are like how many courses they take per semester and all of that. And then you have another function that use a unique ID of a student to get details of that student. So I can decide to come and say, okay, I know my unique number. I want to know my details. I can just decide to come and pass in to call that contract function and pass in my unique ID. Right. So what that means is that function that I call to get my unique to pass in my unique details, right? To pass in my unique identity, right? To get my full details. That function I call serve as my entry point. Somebody might decide to come and say, okay, maybe your level coordinator might decide to come and use the add student details function, right? To add a new student. That add function serve as its entry point. So yeah, depending on what function you're trying to call, determines the entry point that you have. But each function in a contract is an entry point from the outside interface. And yes, again, each class is uniquely identified by a class hash. Yes. Yes. So a class hash basically refers to a unique identifier assigned to a contract in Starknet. So yeah. So this is a very unique feature within the Starknet ecosystem whereby you can have one contract class but has multiple class hash. One contract class but has multiple class hash, so that you can deploy whatever class hash you decide to deploy. So yeah, let's continue our. So yeah, when a class is declared, the network registers it and assign a unique hash known as class hash. Now, a class hash is in Cairo is a contract class in Cairo is the definition of semantics of the contract. It includes the entire logic of the contract, right? Such as the name of entry points, the addresses of storage variables, and the events that are emitted in the contract. So basically, every Starknet contract has three key features, right? Three or more, but when these three are like the very fundamentals of every Starknet contract, right? One is it has the entry point, which are the functions, right? And their logic, right? And then secondly, you have access to a storage variable. And then thirdly, it emits an event, right? Just like when you're coming from Solidity background, you emit event when you write your Solidity contract, right? So the same thing happens here. You emit event when you write your functions within the contract class. And those events are consumed by the external wall. Remember that smart contracts are isolated from the wall, right? They get access from the outside wall, right? So they get access to the data of the outside wall via the Oracle, and they give out data from their own via the event that they emit. So yeah, then then we talk about entry point. So entry points in contract class refers to functions that are exposed in the ABI. ABI means application binary interface, right? So entry points is in a contract class refers to functions that are exposed in the ABI of a contract and can be called from outside the contract class. So yes, this is where the front end part comes in, right? When you go to the part of the front end, you start to hear them calling of ABI. So these ABIs are basically interface that allow you to access functions of a smart contract. So yeah, so before I move on to contract instances, does anybody has any question regarding contract class that you don't understand or anything within that you don't understand? You can just raise your mic and just raise your hand and I will allow you to speak. Yes, we'll definitely share the link to the slide. So yeah, does anybody have any question with regards to what I just explained on contract classes? There's no question. Interesting. So does that mean interesting? So does that mean all of you guys understand what I mean by contract class?
I mean, if you guys are not saying anything, that means he should ask you questions. Since you don't want to ask
Exactly.
questions,
Yeah.
you can just pick randomly from the call. Call like 5 people. They explain what you have explained to be sure they actually understand.
Okay. 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 So who can explain to me what do you understand by entry point? Okay. Should I pick someone from the call? Okay, maybe I should do that. Okay. Moses Sunday, can you explain to me what you understand by entry point? Okay. Entry point of a contract or a program is just like the start of the program, just like say the main function of a contract. Yeah, so I would say this is like a 50-60% on the right path. So when it comes to a contract class, any function can serve as the entry point, depending on who is calling that contract. Yeah, just like the example I gave, right? Just like the example I gave with regards to students and then teachers working on a classroom contract, right? There's a function that adds students and assign a unique identifier to them, and then there's a function that gets student data based on unique identifier, right? So for 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 the teacher, the entry point is him adding a student. And then for you as a student, you're trying to get your details to understand, okay, what are the courses that has been assigned to me this semester? You know your unique identifier. Once you come and call the get the student details and you pass in the unique identifier, it gets your details for you. So what that means is that your entry point is you calling that get student details. Yeah, so yeah, that's basically what entry point is. So yeah, I'm going to, in the absence of any question, yeah, I'm going to go ahead and continue from where I stopped, which is contract instances. So take instances as a deployable contract. So let's go over this slide here. So contract instance is a deployed contract that corresponds to a class, right? Only a contract instance acts as true contract in that they have their own storage and can be called by transactions or by other contract. Is somebody raising his hands? Oh, okay. I mean, if okay, okay. Who's raising his hands? Okay, so if you can't see my screen, I guess most likely is due to network or, but yeah, I'm currently in slide 17. So what you can do is drop from the call and jump back. And yeah, you definitely get to where I am. Yeah. Karin, you can speak up if you have a question.
All right, sir. Thank you. I asked the question earlier, but I don't want you to go that far before you answer me. Probably
Okay.
it was an oversight from you,
Okay.
right? So you talked about Cairo being a native language for Starknet contract. So I really want to like understand what that statement means. Like I was asking, does it mean that it's a native token rather, or what exactly? I didn't
Okay.
really get that part.
Okay. So Cairo is the native language for writing Starknet smart contract. So just like Solidity, right? In Ethereum, you use Solidity to write Ethereum smart contract, right? So yeah. So Starknet, instead of, because of the ability to write provo programs, right, that Cairo give us, we then adapted to use it to write Starknet smart contract. So it's not a native token. It's a language that you use to write Starknet smart contract, just like the language, just like Solidity for writing Ethereum smart contract. I don't know if that makes sense.
Yeah, it does. Thank you. Thank you, sir.
Awesome. So yeah, let me continue from. Okay, so what is a contract instance? So a contract instance is a deployed contract that corresponds to a class, right? So the way it works is, when you want to interact with the Starknet smart contract, that Starknet smart contract has to be deployed before you can be able to interact with it. Just like every other contract, right? Before you can be able to interact with it, you have to deploy it. And a deployed contract in Starknet is called the contract instance. And we use the contract hash. Sorry, we use the contract class to deploy that contract. So yeah, just like the content here says, contract instance is a deployed contract that corresponds to a class, which means you are using a contract class to deploy it. And once you deploy it, what you get is the instance of that contract class. So when you have a contract class that has three functions: add students, get student details, update student record, when you deploy that contract, it gives you a contract instance, and that contract instance will allow you to access those three functions. So yeah, that's in a nutshell, that what basically contract instance means. Now, a contract instance
So,
has a
sorry,
norm.
I have a question.
Okay.
Okay.
Uh,
This second line states that contract instance as a true contract. That is, the act at it as a true contract. It doesn't really mean that they are true contracts. Then, in that case, does that mean contract instance can be likened to factory contracts, whereby you use it to call the original contract? Or does
mm,
that
that's an interesting question. So when you write your contract from your system, you're the only one that knows what that contract does, right? And if you want to interact with that contract, you have to use two things: either deploy it and interact with it, or you write a test for it. I mean, within this bootcamp, you guys will be taught how to write tests, how to test smart contracts. So you see what I mean by that. But yeah, there are two ways for you to interact with it. Either you interact with it via when you deploy it, or you via the tests. So by merely you writing your smart contracts, there's no way you can interact with it unless you deploy it. And when you deploy it, you get a contract instance, which gives you access to all the contract functions. So that's why this statement says only contract instance acts as true contract in that they have their own storage and can be called by transaction or by other contract. So when you write your contract, you don't, how do you test it? Right? How do you interact with that contract? Is by you deploying it. So in essence, your contract instance give you the full picture of what you can be able to do with it. So after writing the contract, when you deploy it, then you can interact with it. So that's why this statement is here. So yeah, the last point here is contract instance in Cairo refers to specific deployment of a smart contract in the Starknet blockchain. Exactly what I just said, right? Some couple of seconds ago. So yeah. So these are like what we talked about regarding contract instance. So just look at contract instance as a contract that has been deployed either on testnets or on mainnet or on reg test, depending on the network you're trying to do or on local. So yeah, does anybody have a question?
Hello. Okay, can you hear me?
Hillary, yes, I can hear you.
Hello, can you... Okay, so on your slide, the third statement says, can you go to see the contract instance has been announced. I don't really understand that statement.
Yes, so nonce it's a value, right, that counts the number of transactions originating from that contract address. So what do I mean by that? When you deploy your contract, the nonce value is 0. When you start to interact with that contract, right, you're basically creating transactions, right? That nuance increase, and that nuance serve as a differentiation factor between one transaction and another. And the nuance is very important for what we call people that validate, like nodes that validate transactions, because they use that nuance to identify one transaction from another. I don't know if that makes sense.
Okay. Okay.
Yeah.
So basically, nonce is the amount of time your transaction or your contract has been run on chain. Basically, right?
Not exactly the amount of time. It's the number of transactions that particular smart contract has executed. So every time you call the address of that contract and execute a particular transaction on it, the nuance increase. And that transaction that you did on that contract has a unique identifier, like a unique transaction, so that the previous one and the new one that you just do will never have the same transaction ID. That's like from a user perspective. From a miner perspective, from a node operator perspective, you use that to sort of like know that, okay, this transaction is different from this. And so that he can actually sort of like bundle them into a block and sort of like prove them in Starknet blockchain. So it's not the the time it takes to execute a transaction. It's the number of transactions that happen from that contract address. I don't know if that makes sense.
Okay. Yes, I understand. Thank you.
Okay. So does anybody have question? I mean, I like that people are putting up to ask questions. So because by you asking questions, that's where you begin to understand this sort of concept. And you can't really fully understand them on the go, right? But when you have a graph of like 30, 40, and then when you go back and go over it and read up on the reading materials that are added at the end of the slide, we get to have a full understanding of what this concept are. And the good thing with the Starknet ecosystem, it's a very accommodative ecosystem whereby you can ask questions and you always get someone that will respond to you and give you a direction on where to get your solution to your questions or bugs that you're facing while working with it. So yeah, let's not waste time here and let's go over to the last topic on this slide before we go and start writing code to see what we've done. So yeah, the third section is functions and interfaces. So yeah, so what are interfaces in Starknet Contract? So look at interface as sort of like the architect that sort of like come and say, okay, this contract that they are trying to build will require this, will require this, will require this. So basically designing how the blueprint of the contract will look like. So yeah, interfaces in Starknet serve as blueprints for contracts, right? They are defined using trade annotation, Starknet interface attribute, right? They define functions that the contract exposes to the outside world without including the function bodies. So they basically define the functions, but without implementing the functions. So all functions in the trade are considered public and can be called from outside the contract. So essentially, interfaces are your blueprints. So take, for instance, the example I gave the other time of a student classroom contract where we have add students, get student by unique ID, and update student record. Now, your interface would define those functions. And what I mean by define is sort of like define the function name, the input parameter that function accepts, and the return value that function return. Remember, so yeah, these are like what it basically contains. So yeah, the second part is functions. Now, functions are the bread and butters of Starknet smart contracts. So when you write Starknet smart contract, you're basically writing function that does one or two things. And functions are interfaces with actual body implementation. They implement the interface definition. So yeah, going back to the example I gave on interface, which defines three functions: add student, get student by unique ID, and update student record. Now, when you come to the function part, you are going to implement those functions, those interface functions, right? So basically adding the meat, the bread and butter that form that function. That's the inner logic of the function. To conform with the input parameters of the function, the input argument of the function, right? And the return value of that function. In cases where the function returns a value. In cases where the function doesn't return a value, it will be like a unity function whereby it doesn't return anything. So yeah, we have types of functions. We have public functions, right? So these are functions exposed to the outside world and can be called by anyone. They are called from the outside the contract or from within the contract itself. So you see, it has two options, right? Either can be called from outside the contract via the API or within the contract. Another function calling that function within that contract. Then the second function type is external functions. So these are public functions that are directly invoked through a Starknet transaction, right? They can mutate the state of a contract. Again, they're quite similar to what we call the public, right? But in the sense that they mutate states. Then we have the view function. Now, the view function are functions that are typically read only, right? They cannot mutate the state of the contract, which means they cannot change the state of the contract. So if you have, like for the example I gave, the add student, get student by unique ID, and update student record. I mean, from these three functions, you basically know that when you come in and pass, you call the get student details by passing in your unique details, you cannot change that that student record. The only thing you can do is pass in your unique function, your unique ID, and you get your details. The other function, which is update student record, that one from the name, you know that is going to update student record. So obviously it's going to be an public or an external function. So yeah, the fourth function is implementing functions. So these are functions that are implemented in an implementation block that match the interface one. This block must be annotated by embodied to expose function to the outside world. So this implementing function is not a type of function. So when you define interfaces, right, when you want to now add the bread and butter of that function, this is where you now come in and you define that implementation part of it, and then you add this annotation to it. We're going to see how that works. So yeah, if anybody has a question from what we just discussed, the interfaces and functions, you can ask here. Otherwise, we'll just go ahead and start writing code. Okay. Okay, I've gotten quite a number of questions. Okay, so the first question says, when you say test, do you mean writing code or deploying on test network? Awesome. So when I say test, I mean, sorry about that. So when I mean test, I mean you writing a test that basically tests your logic. So for example, you write a function that says 1 + 1 is 2. You want to write a test that asserts that 1 + 1 is actually 2. So that's what I mean. I mean writing code to test your function. That's what I mean. I do not mean deploying to test network. So yeah, the next question says, is Cairo different from Starknet contract? So I guess this one came in a bit late, right? But we talked about the difference between Starknet contract and Cairo program. So Starknet contracts are Cairo programs, but they have access to states, right? Which is in this case, state of the blockchain. While your normal Cairo program don't have access to that. So essentially what that means is that a Starknet smart contract, it's a Cairo program with access to blockchain states. So yeah, if you look at the slide, you see the difference that we. Yeah, so this one asks a question. Where can we get our questions answered? Discord, Stack Overflow, both on Discord and on Stack Overflow and on the Telegram groups. So yeah. Okay, somebody slide. Okay, please, interface and functions are like trade. Please, the interface and functions is like trades and implement on Cairo. Oh, okay. So interface are like trades. They are like traits. They are like traits. They are not an implement on enum. So I didn't get the last part where you said an implement on enum in Cairo. Maybe if you can rephrase your question and come back to this. So yeah. So just before we, oh okay, an implement. Yeah, no. So interfaces, right, are like traits, while your functions is basically implementing those traits. Yeah. Patience, can you unmute and ask the question so I can get you clearly? Okay. I guess Patience is having network problem. But yeah, I'm going to, in the absence of any question, we're going to see how to build a simple smart contract, a counter contract actually. So I'm going to stop sharing my screen here and share my vscode screen and pick up from there. Okay, hold on a second. Okay, I'm going to share my screen again. So if you guys can see my screen, just confirm by an emoji. Awesome. So okay. So I'm going to, okay, just a quick question, right? I'm hoping that everybody has set up Scarb and SNFoundry on his system. Can you signify on with an emoji if you have these two tools set up on your machine? Because these two tools, right, are what you use to build your smart contract and to also scaffold a new Starknet smart contract. So I'm going to stop sharing and share my terminal, and then I'll run you two guys the command to. Interesting. So you will need to set up Scarb. What you need to set up SNFoundry, right? So SNFoundry allow you to sort of scaffold a Starknet smart contract. So I'm going to stop sharing and share my terminal screen so you see what I mean by okay. So let's do this. So if you have Scarb, if you can check if you have Scarb installed on your machine by running Scarb -- version. So I currently have this Scarb version 2.7.0. Then I also have my snforge version. So snforge it's a tool that allows you to scaffold Starknet smart contract that pass tests. Interesting. So yeah, you could see that I have when you do snforge, you see that I have this snforge version. So what I'll do is I'll go ahead and like go and do. Okay, somebody wants to speak. Okay, I don't want us to spend so much time on the whole tool terminal thing, right? Because that's not like what we are trying to do here. But yeah, I will entertain the first question. Okay. Okay. The person has stopped, has dropped his mic. Okay.
Okay. Good evening, sir.
Yes, good evening. You can go ahead with your question.
Okay, so I wanted to ask, how do we get the SM foundry? Because we did not
Okay.
install it. No one told us to install. We did not know we were supposed to install. Please, how do we install it? Is this something we can do now?
Okay. So interesting. Yes. So yeah, somebody just dropped a link. Thank you, Eric, for dropping that link. Yeah, this is the link for setting up SM Foundry, right? So I don't know if it's something that we can be able to do on this call. Ezemo. Okay. Let me quickly walk you guys through. If you can see my second screen, it's just so this is the link. This is the link. So yeah, this is the link to. So yeah, you need two things, right? You either install, you need the Scarb and then universal serial compiler. So don't be scared by seeing all of these things, right? Don't be scared by seeing all of these things. So yeah, this is just another tool that we need when you're writing your Starknet smart contract. And you come back to this, you talk about this particular SM foundry quite a lot when you start to talk about advanced smart contract features and also testing smart contract and working with the front end. So yeah, if you have Scarb installed on your machine, you can basically run this command and follow up with this. And if you have ASDF, which was, I am very sure that's where you guys used to install that's what most of you guys used to install your Scarb, you can install it via this command. And if you want to install the latest version, you can install this via this. For people that are using Windows machine, it's a bit tricky, but here you can follow these instructions and you have snforge up and running on your machine. So yeah, that's all about like deploying, right? I'm going to share my other screen, right? And scaffold the so for you, if you have SMForge SMFoundry installed on your machine, you can always do SMForge to know the version. You can always use SMFoundry to know the version, SMForge to know the version that you have on your machine, right? Once you know that, you want to scaffold a new project. And how do you scaffold a new smart contract project with SMForge? It's by basically running this command init, SMForge init, then your contract name. In this case, let's say we want to make it let's say we want to make it counter. Okay, so it's asking me, do I want to do it with SMFoundry or Cairo tests? I want to do it with SMFoundry because I want to test it with the way that you test Cairo smart contracts. Then you have this. It's going to run.
Hello, excuse me, sir.
Okay, you have a question?
Yeah. I don't know if you can hear me well.
Yes, I can hear you.
I was wondering if this SNForge is somehow similar to Scarb.
So Scarb is the language server, while SMForge is a library that allows you to scaffold that does three things for you. It allows you to scaffold a new contract project. That's one. Secondly, it gives you tools for testing your Starknet smart contracts. That's two. The third one, it gives you tool for deploying your Starknet smart contract, which is a bit outside of this scope of this our conversation here, right? So we want to focus on the scaffold, right? Which is what I just did here. The SMForge init the project name you're trying to run.
Okay. To be sure I understand you very well, eh?
Yeah.
Okay. Scarb scaffolds just a simple Cairo program or something like that. But
Exactly.
SNForge scaffolds Starknet smart contracts.
Yes, a simple Starknet smart contract.
All right, I understand now.
Okay, so I'm going to go ahead and stop sharing
Hey,
my
one more thing, please. Can you like allow us that are participating live to kind of install SNForge first, please?
So I don't know if the time we have will allow us to do this. I'm not sure if the time will allow us to do this. But
I think it would be great if like
okay,
they can be able to do it along. So sure, we can go another 30 minutes. I mean,
okay,
it's better to do it well than do it in a rush and nobody understands.
okay. So just a quick question, right? Who has installed Scarb and ASDF on his machine?
I think everybody has installed Scarb. It's what we did in like first and second week. It's just the Foundry or the SN4 rather. I think most people haven't. So the instruction is already in the comments and on the WhatsApp group as well. So just use the link and run it ASAP in like 5 minutes or so. Meanwhile, you can continue, sir.
Okay. So I wanted, if you have, so a quick question again here, right? When you guys are, when you're installing your your Scarb, did you use ASDF or you use the ASDF to install your Scarb? Just a question around.
Anybody can unmute and answer, please.
Yeah. Are you guys lost?
No, with the
Guys
ASDF.
lost?
We use
Oh,
COI.
okay, 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 okay. So if you've not used ASDF, right, a better approach for us here is to awesome, awesome. So a better approach is for us to use the ASDF to install it. So if you go over to this link, the link that my cursor is here, allow you to sort of like install ASDF. And again, how many? Yes. So looking at what kind of machine you're running, right? You can always choose from here. If you're using Bash, you can choose from here. If you're using Bash and Git, if you're using, depending on what kind of what kind of terminal you're using, you can choose from here. But they have three options of installing, right? So you can see the only difficult things they have, they don't have a way for installing this on a Windows machine. So
Hello,
yeah,
sir.
is somebody
Hello,
speaking?
sir. Yeah, can you hear me? Hello, sir. Can you hear me?
Okay, yeah, I can hear you.
All right. Is there a way to check if you are using if you use ASDF to install or you use the other code? Is there a way to check to know which one you've used?
So yes, so a way for you to know if you use ASDF is to try to check to try to install the Scarb version. Is to try to install the SM Foundry. ASDF. Yeah, so I saw a question from the group. So for you to know if you have ASDF is basically for you to run ASDF dash. Wait a second, let me drop it in the. I saw somebody's dropping a question. Is there for you to know if you have ASDF on your machine, you can basically run ASDF dash version. Somebody asks a question, you're recommending ASDF, is anything wrong with Coil? Yes, so Coil at the moment from the documentation you're seeing here, there's no a Coil approach to installing yes, okay. Yes, so you can actually use the Coil to install the SM Foundry. And then from there, you can see what version of SM Foundry you have. So if you run ASDF version and you can't find, like you don't have, awesome. So somebody used the Coil and you run. So Wisdom, can you try to run ASDF version? Like, can you try to run your SM4 version? SM4 dash version. Can you try to run and see what version of SM4 you're using? Eric, yes. Yes. It will install quite a number of packages. snforge version 0.3. Somebody is getting 0.23.3. Okay. Awesome. So how many people have installed snforge? So let me know the number of people that have, so we can move on from here. Okay. So yes, the next thing we want to do is run snforge init counters. snforge init. How do I update mine from version 2.3 to 2. So you can run snfoundry. So yeah, so once you guys have the snforge set up on your machine, right? You want to scaffold a new project. So you can run snforge init counter. So I sort of like drop the link to project configuration. First step, okay. Exactly. So when you come to the first step, you can find it here. snforge init your project name. And what it will give you, this 4 structure. It will give you the scarb.log, scarb.toml, src, and tests. So if you've successfully created a new project, just signify with an emoji. So we know that. Can I get an emoji if you've successfully scaffolded a new project with snforge? This is it. Yeah. snforge init project name. So in this case, we're going to make it count as. Okay. Since I have a number of people that have scaffolded a new project with snforge, I'm going to go ahead and share my editor screen and see what we've talked about. If you can see my screen, just signify with an emoji. Awesome. So if you've opened that new project that is scaffold, right? What did you see from there? Can you see a scaffold project that has this? if you can see a scaffold setup that has this particular project, just signify with an emoji. Awesome. So I'm going to go ahead and, should I say clean up? Yes, clean up this, and then we start from scratch. Don't worry, this is the first of a lot of smart contracts that you guys will write during this bootcamp, right? So if you're lost from the beginning, don't beat yourself up. You can always come back to the recording with the slides, with the links to the resources we are giving on the slides, and pick up from there. So when you're writing your Starknet smart contract, the first thing you want to do is you want to define your interfaces. And the way you do it is you start by adding your traits, your annotations, right? Exactly. This signifies that we are trying to use an interface. Remember I said that our interface are public, right? And then, yep, we define them with traits, right? I counter, right? And we annotate them with contract states. So because we want to have two functions, right? Two functions that basically, yeah, three functions, right? One function that increase the counter, second function that decrease the counter, and then the third function that gets the current counter. And for us to do that, we need access to the states. And what this does for us is we need this. It's a what did I call it? A access to the states, right? T contract states. And the first function we want to have is increments. Yeah. Increments. I'm going to write this, and then after writing the whole interface functions, I'll come and explain what each learner writes in the interface, to see that so that for you guys to understand what I mean by all of this. Ref self T contract states. No, we don't need this. No. Okay. 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 It's also going to contract states, and then fn is going to get current, hold on a second, get current count. And what do we need for it to get the current? we need, oh, hold on. Need this the contract state. And what does it return? It returns to us a U128. Okay. So let me explain what I just did here. Okay, so can you guys signify with an emoji if you're still with me? Okay. So the first two functions, if you can see exactly, I use ref self contract state. Now, so what I mean by ref is you're trying to reference the contract state. Self, right? Contract state. So what it means is that this self argument is referencing the contract state. That's why we have this T contract state. Same thing with this ref self argument is as referencing the contract state. So what it means is that it's not taking ownership of the contract state. It's referencing the state of the contract. Yep. And what it means is that it's a function that changes the state of the contract. That's why it has these two. It has this ref. It has this set of the way of definitions. So for the get current counter, it doesn't change the state of the contract. What it does is it gets the value it gets certain value from the contract. It basically read data from the contract. So if you want to read data from a contract state, you use these definitions. But if you want to write to the contract state, you use the definition. Right? And this is just one way of defining interface definitions. Some function definitions have other argument that you can collect. You can pass in other arguments, but because we don't need it at the moment, that's why we're not passing it. But you can also pass in other argument to this function, not just the contract state. So are we clear on how we define our interfaces in Starknet smart contract? Oh, okay, increase the font. Interesting. How do I increase the font? Okay, just give me a second. Awesome, awesome. Thank you.
Use command plus button.
Yeah. Is it clear now? Can you all see? Is it bigger now? Awesome, awesome. So this interface has three functions, right? It has the increment, decrement, and get current count. The first two functions change the state of the contract. That's why we reference the state. While the third one just read from the state, doesn't change anything from the state. Can we also declare variables in our interface? No. So interface basically define the functions, right? What the functions accept as argument and what they returns. So if you can see here, they accept the state and they don't return anything. They mutate the state and they don't return anything. That's why they don't have this. They don't have this return value. But for this return counter, it reads the state. That's why it has this way of definition. And then it returns a value. The part where you declare variable is when you're trying to implement the functions. So yeah, let's go ahead to the parts where we implement the functions. Okay. So now, remember I said when you want to implement, you start with what we call contract, right? You start by an annotation called contract. That signifies that you want to write contract here. Yeah. And you define it with any name that you want, but in this case, we are going to make it counters. Yeah. And what does that mean? You can define it anything. I mean, we can literally define it. We can literally define it anything that we want, right? We can actually make it to be simple counter. Simple counter. Yeah. And when you go in, because we are trying to mutate states, we are trying to increment a counter and decrement a counter, we need to define what we call storage slots. Remember, all through this class, I've been talking about persistent data, smart contract, modify state of the blockchain, persistent storage, state, and all of that. So now this is where you now define it. And again, if you want to define a storage in smart contract, you have to define it with this keyword storage. Yeah. With the keyword storage. And here we want to make it counter. It's yes, so simple counter is our class contract that is going to implement the interface we define. Yes, so mode is module, is what we call module. So we are trying to tell Cairo that, okay, this is a module. See this as a module, right? Just like I said, right? Starknet smart contract, it's a module in Cairo. It's like it's a program in Cairo, right? So yeah, this is it. Now, you define a storage slot that allow you to create a storage space on the blockchain and mutate the state of that storage slot. Now we've done that, right? I mean, you all are aware of this, right? From your Cairo sessions, right? This is a storage, this is a struct that has a counter, and the counter is item has a value of 120, has a storage log of 128, right? Now, again, a contract has what we call a constructor. And a constructor, from your programming experience, we all know that a constructor is that one particular function that is executed only once. The moment you run that class, the moment you deploy that contract, that function, it's called only once. And that's where you set your ground rules, right? Okay, you set your foundations, right? So just look at storage constructor as that one function that get executed only once when the contract is being deployed. So yeah, we're going to look at that here also. So what we want to do here is we're going to create a constructor that sets the counter value to 0, or however you want it. Let's say you want the counter to start at 50. So every time somebody deploy your contract, let the counter start at 50. You can define that. And if you notice that the counter, the constructor is not part of the interface, yes, that is done by design. So this is done by design. So we want to have access to the state and initial val, right? Which is a U128 value. Yes. And what we want to do is basically write to this storage slot that we just create. Yep. Initial value. Remember the ref, right? Remember the ref. This ref gives us access to the states. Ref, contract states. And remember I said storage is kept in the contract state. So now we can basically do self. Oh, then a second. This is the language server trying to shout at us. Self, the self give you access to the storage slots, to the contract state. So you basically do it this way. Self dot counter dot write. You're trying to write, right? So there's two ways here, right? You either write to the state or you read from the state. And because our constructor is trying to set an initial value for these storage slots, you're going to write to the state. I'm going to have what initial val. And remember, it's not returning anything. And from our Cairo background, when you don't want to return anything, you don't have to add a comma here. You can basically leave it that way. It means that it means that this is a unity function that doesn't return anything. We set our storage slots and we are done here. Now the next thing we want to do is we're going to implement the bread and butter of our iCounter interface. I don't know if you guys are with me, just signify with an emoji so that I know that I'm not speaking to myself alone. Awesome. 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 So yeah. So let's awesome. Remember there was a part in our there's a part in our code in my slide where I mentioned this, right? This ABI embed, right? Aha. So this is an annotation that tells that, okay, expose this to the ABI. Expose this function to the outside world via the ABI, which is our application binary interface. And for us to implement that counter, we basically do no, don't want to follow what the compiler is saying. Simple counter of. Now I want to reference this. And for me to reference this, there's two ways I can do it. It's either I import this interface into this module, or I use what we call super. I like to use that super because it gives me access to the state that is above it. Okay, somebody's asking a question.
Yes, I have a question, please.
Okay, you can go on.
Please, can you like repeat what you mean by this line 23?
ABI, exactly. So this is an annotation that tells the contract to expose whatever function that is under this implementation block to the outside world via what we call application programming, application binary interface. So just look at it as your equivalent of APIs in Web 2.
Okay, I understand now.
So you have, when you deploy your smart contracts, your contract instance will expose functions that this has been that this implements.
Okay, all right.
So remember when we expose this counter, we access the state, right? Now here we are going to access the real state here. We're going to access the real state here. And if you look at it, the compiler is shouting at me, right? Let's look at what the compiler is saying. Not all trade items are implemented. Missing, increment, decrement, get current counter. So whenever you do this, whenever you are trying to implement an interface, you have to implement all the functions of that interface. If not, your contract will not compile. And if your contract does not compile, there's no way you get a class hash, and there's no way you'll be able to deploy on either testnet or mainnet. So yeah, and a hack that, not like a hack, but a good thing I always do is to always copy the functions like this. Now, and implement the bread and butter of the contract. So now, what do we want to do? From the name, right, it says increment, right? So first off, we want to read to know the, so when you say increment, right, you want to increment the counter. So what that means is that you have two options, right? Either you, every time somebody call a function, you delete everything from the counter and start from 0, or you read the last value of the counter and update it. And because it's increments, that's exactly what we're going to do here. We're going to read from the state to know the last state of the contract, the last state of that contract state, and then increment it by 1. So yeah. So I'm going to start with calling this current count, self.counter.read. Exactly. So you see, the first time I said write, right? I'm writing. Second one I'm reading. That's why we have this read. Okay, somebody has a question?
It's not really a question. Please, can you scroll up like your first lines of code?
First line, this.
Okay.
You mean this?
Yeah, okay, I've seen it. Thank you.
Okay. Oh, please, can you collapse the names, that is the files place, so that everything will be visible? Thank you.
Now, this is it, right? So the next thing we want to do is, it's increment, right? So want to write, right? Read, want to write the current state plus 1 because we're trying to increment it. So what do we do now? We basically say self dot count dot write counter current counter plus 1. And essentially we are done with the bread and butter of this particular function. Yeah. And we'll go ahead and implement the next function. Notice the compiler is not referencing me. Okay, so the same thing that we did here. Yes, so there's something I'm not sure if anybody has noticed it, but if you can see here, okay, what's shouting? Somebody's okay. If you look at it very well here, I'm using T contract state here, but here I'm using contract state.
Yeah, that's what I was looking at, but
exactly. So here you are trying to mutate the state. You're trying to say, okay, you're trying to mock the state. But here you're actually accessing the actual state. So you can name it whatever you want. Some people do this like this. Some people do make it like this, T states. Some people make it like this, T states. Or some people make it T contract states. I prefer T contract states because it tells me that okay, it's a trait that is trying to access the state. So when I'm implementing it, I'm accessing the state. So yeah, here you are accessing the actual state of the contract. Yeah. So here we are trying to decrement, right? And to decrement, we need to know the current state, and then we write -1. Yeah. So current dash counter dash count, right? Again, self, right? Self give us access to the storage contract state, right? The contract storage state, which is in this case counter dot read. Now we want to decrement it, right? So we say the dot counter dot write, yes. And what do? We say current counter minus, okay, hold on, -1. Yep. If you, does anybody understand what I just did here? Awesome. So we have one last function that we need to implement, and you can see already the compiler is shouting at me that look, yes, you still have one function that you've not implemented. So let's go on. Aha, can you see? Aha, so exactly. So in this case, we are trying to read the current counter, right? The current count. So you can say self dot counter dot read. Exactly. So by mere this line, it returns you this U128. Can you see here? Yep. It returns you because here is a U128. So whatever you read from here is going to return a U128 unsigned integer of 128 value. So yeah, so can you see the compiler has stopped shouting at me? So yeah, so essentially we are done. We are done with that. We are done with implementing the interface of this I counter. So does anybody has any question?
Can you please just go over it once again, like just to like?
Okay. So
Thank
yeah,
you.
so here, first off, we define the interface. Public trade I counter T states. So like I said, right, interfaces are like the blueprints of what your contract will implement. Yeah. Let me go over them again, then I can ask. You can ask.
Sorry, my question is kind of related to what he asked.
Okay.
Okay, while you are going over it again, can you like please be telling us like the meaning of these keywords such as pub, trace, ref?
Oh, okay. Okay. So yeah, pub trade I counter. So basically what this means, this means it's pub. Pub means this is a public interface. And trade it's an interface definition, right? That tells you that this is interface. You're trying to define an interface. So trade basically allows you to define interfaces. So that's what basically this means. And then I counter, that's the name of the interface you're trying to create. Yeah. Then the T counter, the T contracted. In this case, you're trying to say that okay, this interface will have access to this.
Sorry.
Okay.
I did not really understand what you said about pub and trace. Please.
So trade, it's sort of like a language syntax that tells us that we are trying to create an interface. So what that means is that you don't necessarily have to like re-implement the functions. Like you're trying to sort of like define certain functions and then implement those functions later on. I don't know if that makes sense.
Yeah, I got it.
Okay. So then we have the three functions here. We have the increments, which reference the state, right? Contract state. So it's sort of like a norm within the space to be using self when accessing the contract state. So here we are referencing the contract state. And just like I said, this T contract is mocking the contract states. Same thing here. And this function here means this, because we're referencing, we are making use of this ref, it means that this is going to be something that is going to be a write operation. Sort of like we're going to change the state of the contract. That's why we're referencing it. And for the get current counts, we are taking a snapshot. This icon is giving us a snapshot of the state. This symbol here tells us that okay, this is a snapshot of the state. Because we're just reading the state, we're just reading the value of a certain value from the state. You don't need to reference it. You can just take a snapshot of the state. And that's what we're doing exactly here. We're taking snapshot of the states to read the value from the state. Yeah. Then we come down here. The first thing here is the contract annotation. Yep. Which says that this whole module is a contract. And this is a key differentiating factor between a Cairo program, and a Starknet contract. Starknet contract will always have this key, this annotation that signifies that this is a Cairo, this is a Starknet smart contract. So yeah, this is it. Then we have this, so you can define the name, whatever name you want, right? But essentially, is you're trying to create a module, which is a Starknet smart contract. Okay, let me try and answer the question from the incoming message here. Does T contract state have a value? Oh, so T contract state is trying to mock the what we call the state of the contract. That's why when you come back to the interface, when you come back to the implementation block, you are replacing that T contract with the actual contract state. So it has value, and that values are essentially the storage here. I don't know if that answers your question. So the last one says pub mode simple contract is defining our overall smart contract like Solidity to start a contract. Exactly. So you're essentially saying, okay, this module is a contract. And the first thing we did, we defined a storage slot. So a lot of the time, right, smart contract, you're basically changing state, right? So you need to define those states that you'll be interacting with. If, for instance, this is a student record sort of, right, basically have a struct that has a lot of data here, maybe the name, the level, the number of courses the person is taking, and so many other things we can have it here. But because this is a simple contract that basically changes state, that's why we're having this. A storage that has one value, which is the counter, and that counter has a U128 value. So yeah, then we go to the constructor, right? And just like I said, the constructor is that one particular function that runs whenever the contract is deployed. It only runs once. That's why it's not part of the interface. And you can think of a constructor as that function that allows you to set the ground rules of your contract. So let's say, for example, you're trying to define the basic setup of the contract. Let's say you want to set up like the name of the owner of the contract. Essentially, what most people do with it is instead of the contract owner, right? So doing that, it basically means that you want to restrict who can do certain things within that contract, right? So that whenever somebody wants to interact with the contract, you call that, check the owner. Is he the owner of the contract, or does he have permission to do that? These are like some of the things you can define it there. But in this case, we set an initial value. So most times people set it off to 0, so that next time you read it, you can actually get the value of 0, and then you can update the value from there. Then I come back to this part, which is the ABI embed. So this is an annotation that tells that expose the implementation details to the outside world, such that anybody that has the ABI can access the functions defined within this implementation block. That's basically what this ABI embed does for us. And then, yeah, here. Remember I said this is our interface, right? Down the line, we're going to implement those interface. And that's exactly what this is doing here. Simple counter of super, right? It's trying to get what is above, what is outside this module. And what outside this module is the counter. So this super basically give you access to items that are outside the simple counter module. And what we want to get is the I counter. And this is what we have here. Okay.
Yeah. Is it possible to like implement, like to write because in line 22 down without kind of defining interfaces?
Line 22, I don't get that. Can you come again?
Like, is it possible to define functions, smart contract functions, without defining an interface?
Hmm.
Okay, it's not possible in Cairo.
So far from my experience, I've not seen. Yes, it's possible. It's possible. There's something called, I don't know if it is still within the scope of, but I will mention it here. So for those that are curious can go over it and sort of like try to understand what that means. Generate dash trait. So you can essentially use something called generate thread. Essentially do something called generate thread, and what that does for you is it allows you to create functions that don't have interfaces, and you can basically do something like this of super counter, and then you have access to your states, and you have access to your states. And you have access to your states in that case. And what this means is this particular it generated declared for you. So not like you won't have, but then it's going to generate it for you without you having to do it yourself. So yeah, that's basically what that. So essentially every contract will have a trade, but there are some annotation that you do that will does it for you. And there are some that you have to do it yourself. And in this case, we have to do it ourselves. So every contract will have an interface, but how the interface is defined depending on how you implement the contract. I don't know if that answers your question.
Yeah, it does. Thank you very much.
Okay, awesome. So yeah, we have this, right? And essentially this implement counter is trying to implement all the functions from this thread. So basically trying to define the bread and butter of these functions. And this is what we did here.
Can you close your I wanted to say you close your terminal so I can see the rest of the screen.
I didn't get that question. Can you come again?
I wanted to ask you, please close your terminal so you can see the rest of the screen, but you scrolled up already.
You close the terminal.
Yeah, it was blocking the rest of the code.
Okay, what part of the code? Here? So I can deploy, I can push this to GitHub and share the link for you guys, right? But Wednesdays and Friday class, you go in depth into this writing smart contract, right? And see what's possible with writing Starknet smart contract. If there's not any question here, what I will do? Okay, somebody's trying to ask a question.
Yeah, like normally we used to run our Cairo codes with Scarb, right, on a local machine. So I was on. Can you hear me?
Yes, I can hear you.
So I was wondering if we can like do the same to this our smart contracts on a local machine.
You mean build, right?
Yeah, compile, be run
Yeah,
or build
compile.
something.
Yeah. So that was exactly where I'm heading to from here. So once we are done, what we want to do is find a way to compile this. And that's exactly what I'm going to do here. So, okay. So I'm going to, so the essence of the Scarb is to sort of like compile the Cairo program for you, right? So I'm going to do Scarb build. So what this does is going to build the project for us. So yeah, it has built. So I mean, we are lucky we don't have any errors here, right? So yeah, can you see it's created a target folder for us that has everything here. So yeah, another thing we can do is we can format it, Scarb FMT. Basically format the contract for us, like format it, make everything align, right? So you could see everything that you're doing. So yeah, this is like the code part of the whole session right here. If anybody has any question, I will answer. And in the absence of any question, I will go ahead and deploy this contract, right? And take it off from here. Okay, can you guys hear me? If you guys can hear me, just signify with an emoji. Oh, awesome. So far, right? Can anybody give me like just give me an idea of what he has learned through this class today, right? And from your experience, sort of like from your programming experience, what do you think is possible with writing smart contract in Starknet? Just an open space here. Okay, so should I make it like a question? Okay. In the absence of any question, what I'm going to do is I'm going to push this to GitHub and share the link I'm going to share the link with you guys. Then apart from that, on the slide, I added 2 links which are very important. I always go back and refer to them whenever I'm working with Starknet smart contracts, which is the Starknet by example and the Cairo book. Yep, the Cairo book. It has a lot of things we can learn from. I always refer to this myself. And the good thing is that they keep updating this here and then. They like every time there's no changes to the Starknet implementation, it comes here and keep updating it. And then if you want to learn to see what's possible, what you can build, you can follow this material. It's Starknet by example. It basically shows you what you can actually build with Starknet smart contracts. You could see a lot of things we could build here. You could build upgradable contracts, you could build DeFi, you could build NFT, you could build time lock, stacking, crowdfunding campaigns, a lot of things we could pick up from there. Account abstractions and all of that. So for me, this is like my go-to book every time I'm working on Starknet smart contracts. I always come back to these 2 books to refer to them and look at what has been done there and pick up from there. So yeah, that's all for this session. If there are questions, I'm open to answer them. If there are no questions, I'm always in the Discord, right? In you guys Discord, you can always ask questions and tag me, and I'm always available to respond to those questions. So yeah, there are no questions. Interesting. Maybe I should ask 2 questions before we leave here. So what happens if you do not implement, if your implementation does not implement all the functions defined in your interface? Can you guys signify with an emoji if you guys can hear me? Awesome. So what that means is that if your interface trait define 3 functions, your implementation block of that interface trait will have to implement all of those 4 functions. Okay, if this is what you guys, if this is like one of the few things you guys are able to pick up from here, then I would say that you are on your track to become a very incredible Starknet smart contract developer. So yeah, GIDA, you can take it from here.